Hi students, in this video I'll be going through the 2013 O-Level Additional Mathematics Paper 1 question 11. So this is a question regarding differentiation and stationary points. Okay, so let's read the question. The equation of a curve is y equals to x squared over x plus 2. So for part 1, they want you to obtain expressions for dy dx and d2y dx squared. So we are going to differentiate this particular equation two times, all right? So let's do dy dx first. Okay, so over here you see that there's an x term in the numerator as well as the denominator. So this means that we will need to apply the quotient rule. Okay, so for the quotient rule, we will differentiate the numerator first. Okay, multiply it with the denominator. Okay, then always minus. Okay, now we will write down the numerator and then we will differentiate the denominator. Okay, so if we differentiate x plus 2, you'll just end up with a 1. Okay, so it's just like this over the square of the denominator. Okay, so we'll just simplify the numerator a bit. So we get 2x squared plus 4x minus x squared over x plus 2 squared. Okay, so just simplify. Okay, the top, so you get x squared plus 4x over x plus 2 squared. Okay, so this will be the dy dx already. There's nothing that we can do to simplify this any further. Okay, you also do not need to factorize out the x on the top. Okay. Alright, so now we're going to find the 2y dx squared. So we're going to apply the quotient rule one more time to this dy dx. So the 2y over dx squared. Okay, so once again, we're going to differentiate the numerator. So we differentiate the numerator, you will get 2x plus 4. Okay, multiplied by the denominator. Okay, minus. Okay, now we'll leave the numerator. And then we will differentiate the denominator. Okay, so you need to use the chain rule to differentiate the denominator now. Because there's a square outside. So the 2 goes in front. Then x plus 2. Okay, the power reduced by 1, so become just 1. Okay, then you differentiate inside, you will just get a 1. So if you multiply a 1, it's just 1. Okay. Okay, then square of x plus 2 square will become x plus 2 to the power of 4. Right? Okay, then from here, you need to ask yourself, what can you do to simplify this particular expression? Okay, so you should see that you can, okay, there's a common factor x plus 2. So we'll be able to take out the x plus 2, right? So let's take out the x plus 2. So x plus 2. Okay, so over here, you are left with 2x plus 4 and another x plus 2. So you must always check, you multiply back this one. Do you get back the terms over here or not? Right? Okay, minus. Okay, we've taken out the x plus 2, so left with a 2 and x squared plus 4x. Okay, then x plus 2 to the power of 4. Okay, then over here, what we want to do is we want to simplify inside this square brackets. Okay, but you should also notice that over here you have the x plus 2 term, right? So you can cancel off with one of the x plus 2 terms below. Okay, so it's below is x plus 2 to the power of 4, which means that this will just leave the bottom with x plus 2 cubed, right? Okay, then now we simplify inside the bracket. So expand. Okay, so we will get a 2x squared plus 4x plus another 4x plus 8. Okay, then expand this negative 2x squared minus 8x. Okay, so the 2x squared and the 2x squared will subtract itself away. Okay, same thing for this 4x plus 4x, you get 8x, right? So it subtract away with this 8x. Okay, so in other words, you are just left with this 1, 8 on top already. Okay, so 8 over x plus 2 cubed. Right, so this would be your d2y dx squared. Right, so the first derivative and the second derivative, they have asked you to, you have found out, okay? All right, let's read part 2 of the question. Okay, so part 2, they want us to determine the nature of each of the stationary points of the curve. So before we determine the nature of the stationary point, of course, we need to know what are the stationary points first. So we know that at stationary points, the gradient is 0, so dy over dx will be equal to 0. Okay, so let's find that out first. So at the stationary points. Okay, so dy over dx is equals to 0. Okay, so the dy dx expression that we obtain is over here, right? X squared plus 4x over x plus 2 squared. So x squared plus 4x over x plus 2 squared equals to 0. Okay, so this means that x squared plus 4x will be 0. Okay, so we're going to factorize out the x to get this. Okay, so either x equal to 0 or x plus 4 equals to 0, which means that x equals to -4. Okay, so this is the x coordinate of the two stationary points. Okay, so let's find the y coordinate also. So when x is equal to 0, basically you sub it back inside the original equation. Okay, sub it inside here, okay, to find the y coordinate. Okay, so in this case, you sub x0 over here, okay, x to be 0, then you have 0 square over 0 plus 2 is still be 0. Okay, so in other words, your curve passes through the origin now. Okay, so y will be equals to 0. Okay, then for this one, you will sub x equals to -4. So the equation of curve is x squared, so -4 squared over x plus 2, right? Okay, so you get this. Okay, so from here you'll get 16 over -2, which is -8. Okay, so in other words, you get the two stationary points already. Okay, so the stationary points are 0, 0, and -4, -8. Okay, so now we need to determine the nature of these two stationary points. Okay, so we're going to take the x value and sub into the d2y dx square. And if you recall, if d2y dx square is positive, means it's a minimum point. If d2y dx square is negative, means it's a maximum point. Okay, so let's do for the 0, 0 first. So for 0, 0, d2y over dx square. Okay, so remember d2y over dx square is 8 over x plus 2 cube, right? So x is now 0 plus 2 cube. Okay, so this will give us 1. So it's greater than 0. Okay, so what you write is that since d2y over square is greater than 0, 0, 0 is a minimum point. Okay, so this point is a minimum point. Okay, let's do it for the other point. Okay, so for -4, -8. Okay, we're going to sub inside the d2y dx square. So we'll get 8 over -4 plus 2 cube. Okay, so this will give us -1. So 8 over -2 cube. So 8 over -8, which is less than 0. Okay, then since d2y over dx square is less than 0, okay, -4, -8 is a maximum point. Okay, so maximum point, minimum point. Okay, so this one you may think is a little bit weird. How come the maximum point is at y -8, and then the minimum point is at 0? Okay, the y value is 0. Why is the minimum point, right, higher up than the maximum point? Okay, so I plotted out the graph using decimal, so we can actually head over to take a look, right, at how it looks like. Okay, so you can see over here, this is how this graph looks like. Y equals x squared over x plus 2. So it's actually a disjointed graph. That means there are two parts of the graph that are not linked together. Okay, so you can see over here, the minimum point is 0, 0, and the maximum point is -4, -8. Okay, so this is a disjointed graph whereby the two parts of the graph are not linked together. Okay, in fact, there's an asymptote, right, at x equals to -2. Because you think about the equation, if you sub -2 inside the x, the bottom is going to be 0, which is undefined. Okay, so this curve can never have a x value that is -2. So the curve doesn't cross the line x equals to -2. Okay, so this is how it works, right?